Hi, I am Swarupa Sail, course instructor for Fluid Mechanics. In this presentation, we will find out what do we mean by capillarity, and we will solve problem to find capillary rise and capillary depression. Here we can see a container in which there is water. This is what is general level of water, and there is atmospheric pressure acting on the surface of water because container is open to atmosphere. This is a glass tube of diameter d which is inserted into the water, and sigma is the surface tension which is acting on the surface of the liquid, and theta is the angle between surface tension and the vertical axis of the glass tube. When tube is inserted into water, there will be rise of water into the tube up to a height h. And here there is a container in which there is mercury. This is the general level of mercury, and atmospheric pressure acts on the surface of mercury as this container is also open to atmosphere. There is a glass tube of D which is inserted into mercury, due to which there is fall of level of mercury from the general level up to a height of h. Sigma is the surface tension which acts at an angle theta from the vertical axis of the glass tube. For water there is rise in level of liquid, and for mercury there is fall in level of liquid. So capillarity is the rise or fall of liquid surface in small tube with respect to the adjacent general level of liquid when tube is held vertically in the liquid. Now we will find out the expression to find capillary rise. Under equilibrium, two forces are acting on the water inside. The first one is weight of water column, which is at a height of h, and the other force is the upward force acting on water due to surface tension sigma. So we will equate both the forces, one which is acting downward and the other which is acting upward. We will equate both the two vertical forces. So first one is the downward force, that is weight of liquid W of height h in the glass tube, and second one is vertical component of surface tensile force. We will enlarge this portion. So W is weight of water of height h in the glass tube, and to find vertical component of the surface tension, we will resolve this force into horizontal and vertical component. Sigma is a surface tension which is acting tangentially to the liquid surface. So we will resolve it into horizontal and vertical component. This is angle theta. So horizontal component is sigma sine theta and vertical component is sigma cos theta. We will equate weight of liquid to the vertical component of surface tensile force as it has been mentioned. So we will write W as it is, and vertical component of surface tensile force acting along the circumference. We will find out expression for this later on. W is weight of the liquid, which is nothing but mass into acceleration due to gravity. We will write mass in terms of density. As we know, density is equal to mass by volume, so mass will be density into volume, and G we will write as it is. So density is written as rho and volume is area into height. So area of glass tube which is of diameter d. So area will be pi by 4 d square into height is h. G is written as it is. Circumference of the glass tube into vertical component of surface tension will give us vertical component of surface tensile force which is acting along the circumference of the glass tube. So circumference into vertical component of surface tension force is mentioned here. Circumference is pi into d. And vertical component of surface tension is sigma cos theta. So as we need to find expression for capillary rise, H will be equal to 4 sigma cos theta divided by rho g d. Theta between water surface and glass tube is approximately taken as equal to 0, hence cos theta will be equal to 1. So final expression for capillary rise is equal to 4 sigma divided by rho gd. We will name this as equation number 12. To find expression for capillary depression, we will use the same expression, that is H is equal to 4 sigma cos theta divided by rho gd. For water, theta was taken as approximately equal to 0, but for mercury, the angle theta is equal to 130 degree. Now we will solve a problem to find capillary rise and depression. We are asked to find capillary rise in a glass tube of diameter 2.5 mm when immersed vertically in water and also in mercury. Surface tension for water is given as 0.0725 Newton per meter and for mercury it is 0.52 Newton per meter. The angle of contact between mercury and tube is given as 130 degree. To begin with, we will write down all the data given. First one is diameter, d is equal to 2.5 mm. We will convert this in terms of meter. So we get it as 2.5 into 10 raised to minus 3 meter. Next is surface tension for water, which is given as 0.0725 Newton per meter, and for mercury surface tension is 0.52 Newton per meter, and angle of contact between the glass tube and the surface level of the mercury is given as 130 degree. So theta m is equal to 130 degree. With these data given, we need to find capillary rise for water and capillary depression for mercury. For water, we have expression to find capillary rise as H is equal to 4 sigma divided by rho gd. H is written as HW as it is for water, so subscript represents the type of fluid or liquid under consideration. So HW is equal to 4 sigma W, that is surface tension for water divided by rho W, that is density of water, into GD. So 4 is written as it is and surface tension for water is given as 0.0725 divided by density of water is 1000, G is 9.81 and diameter of tube is 2.5 into 10 raised to minus 3, which will give us the value of capillary rise as 0.0118 meter. Now we need to find capillary depression for mercury. We will use equation H is equal to 4 sigma cos theta divided by rho gd. Since fluid under consideration is mercury, we will write it as Hm is equal to 4 sigma m, that is surface tension for mercury, cos theta is written as it is. Density for mercury is represented by rho m and Gd is written as it is. So 4 into surface tension for mercury is given as 0.52 and angle of contact is 130, so we write it as cos 130 degree divided by density of mercury. We are not given the value of density of mercury, so for that we can use the equation G is equal to density of mercury divided by density of water. G is specific gravity, which is equal to density of fluid divided by density of standard fluid. Here fluid under consideration is mercury, so we write it as rho m divided by density of water, which is standard liquid. Specific gravity of mercury is known, which is equal to 13.6. Rho m is written as it is and density of water is 1000. So we get rho m as 13.6 into 1000. So we write the value of density of mercury here, that is 13.6 into 1000 into G is 9.81 and diameter of the tube is 2.5 into 10 raised to minus 3. When we calculate, we get the value as 0.004 meter. Here negative sign is used, which indicates that there is a capillary depression. Thank you.